Now we're going to take up one more problem on shaft. The problem number 24, it treats as a solid shaft of 200 mm diameter has the same cross-sectional area as that of a hollow shaft of same material with inside diameter of 150 mm. Find the ratio of powers transmitted by both the shafts at the same angular velocity. So D is 200 mm. So Di will be equal to 150 mm and the cross-sectional area of the solid shaft, which is AS, will be equal to pi d square by 4, which will be equal to pi by 4 into 200 square, which is equal to cross-sectional area of the hollow shaft. Similarly, pi by 4 into d naught square minus di square, which will be equal to pi by 4 into d naught square minus 150 square. So as we know, as both the shaft has got the same cross-sectional area, that's what he says, AS will be equal to AH. So equating these two, so that means pi by 4 into 200 square equals pi by 4 into d naught square minus 150 square. So pi by 4 get cancels. So as external diameter of the hollow shaft, which is d naught, is 250. So here, so therefore, external diameter of the hollow shaft d naught will be equal to 250 mm on simplification. So the maximum torque transmitted by the solid shaft Ts will be equal to pi d cube by 16 into tau s. So pi into 200 square into tau s divided by 16. So that will be equal to 500 into 10 to the power of 3 into pi into tau s. Similarly, the maximum torque transmitted by the hollow shaft Th will be equal to pi by 16 into, open the bracket, d naught to the power of 4 minus di to the power of 4, close the bracket. The entire thing is divided by d naught into tau h. So that will be equal to, substitute the values, pi by 16 into 250 to the power of, open the bracket, 250 to the power of 4 minus 150 to the power of 4, then divided by 250, close the bracket, into tau h. So that will be equal to 850 into 10 to the power of 3 into pi into tau h. So as the speeds and the material of the shafts are same, therefore ns will be equal to nh and tau s is equal to tau h. Therefore, the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will be equal to torque transmitted by the hollow shaft by torque transmitted by the solid shaft, which is, that is, nh by ns will be equal to th by ts. So you take that 850 into 10 to the power of 3 into pi into tau h divided by 500 into 10 to the power of 3 into pi into tau s. So 10 to the power of 3 into pi into tau h and 10 to the power of 3 pi into tau s cancels, which will be equal to 1.7 as tau h is equal to tau s. So therefore, the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will have the ratio will be equal to 1.7. So this is how you will be able to analyze and solve this particular problem. Thank you.